Many beginner prospectors think gold nuggets just sit there in the ground, waiting to be found, like they've been in the same spot for 2.5 billion years. But then you hear old-timer stories about finding nuggets with holes in them, holes shaped exactly like tree roots. But trees didn't exist 2.5 billion years ago. So how did that happen? Hey guys, Bruce the part-time prospector here. And today we're discussing how gold nuggets actually form. Not textbook waffle, but the practical stuff that changes how you prospect. If you understand how gold gets into where it is, you can stop guessing and start making informed decisions. There are three aspects to cover. First, there's the primary gold, which is your classic reef gold. Then this transported gold, also called alluvial gold. And lastly, supergene enrichment. So let's start at the beginning. In Western Australia, about 2.5 billion years ago, superheated fluids, some say as hot as 400 degrees, started carrying dissolved gold upwards through cracks and faults. But as physical conditions changed, such as a drop in temperature, pressure, or ongoing chemical reactions with differing rocks, gold started to come out of solution. I'm not going to go into too much detail here, but if you're interested, I have a link down in the description to a video I did explaining the formation of gold in veins in detail. Over time, the surface of the ground starts to get weathered away and slowly reveals these gold-bearing structures. The quartz vein bearing the gold starts to encounter atmospheric oxygen and groundwater, which in turn starts to react with sulfides in the vein. As these sulfides start to oxidize, they generally expand in size and force the vein to break apart and any gold inside it to be released into the surrounding. So that's how gold is delivered into the environment that we're familiar with. But here's where it really gets interesting for us prospectors. What happens after the quartz vein breaks apart? When the reef weathers and the quartz crumbles, gold is released into the landscape. But here's the kicker. Gold is heavy. And there are only two forces that can move it. And we're talking the big gold here. Gravity on steep slopes and fast-flowing water. In WA, the big movers happen during intense winter downpours, basically fast-moving floodwaters. But even then, gold only generally moves a short distance before it finds an excuse to stop. Gold is lazy. It doesn't want to move. So anytime it can find a gold trap, such as tree roots in a creek, banks, rock bars crossing drainage depressions and bedrocks, inside bends of creeks, anywhere that the water slows down, gold drops out of the flow. Same thing on slopes. As soon as the gold starts to move, it's looking for the first bit of flat ground, or the tree root, or something like that, and the gold will stop, and very soon get covered up by other material. As I mentioned, that gold was heavy, but most people have no real idea how heavy it is. Most elements have a property called specific gravity. This is the weight of an element per cubic centimeter divided by the weight of 1 cubic centimeter of water. Okay? The standard is that 1 cubic centimeter of water weighs 1 gram. Sorry for American viewers, but we talk metric here in Australia. Quartz has a specific gravity of 2.65, and specific gravity is also referred to, and I will be referring to it as Sg. Lead has an Sg of 11.34, so saying lead is 11.34 times heavier than the same volume of water. And gold has an Sg of 19.3. That's 19 times heavier than water and roughly 8 times heavier than quartz. So let's put this into a bit of a real-world example. Imagine your standard 6x4 garden trailer. It has sides of approximately 1.8 meters long, 1200 millimeters wide, and sides about 0.3 of a meter, or 6 foot by 4 foot by 1 foot for our American viewers. Now let's imagine that the trailer is filled right to the brim of the water. Imagine no rust and it's perfectly waterproof. It holds all the water. That trailer is going to hold, based on those measurements, 0.648 cubic meters, or 0.64 tons of water or 1,400 pounds. Please don't post in the comment that sort of weight would exceed the trailer's legal towing weight. That's not the point. I'm talking about the weight the trailer can hold. Now let's imagine, just for the fun, it is full to the brim with molten gold. I'm sure the suspension will never hold it, but just imagine. Same volume, just full to the top with molten gold. Now holds 12.52 metric tons of gold, or 400,000 ounces of gold. So using today's gold price of $7,000 an ounce Australian, or 4,900 US, which by the time you watch this video may seem excessively high or excessively low, that trailer load is now valued at approximately, and I'm rounding here, 2.83 billion Australian dollars, or 1.9 billion US dollars. Incredible amount of money for a trailer load of gold. I have to admit that I did have to use AI to generate this picture, as it didn't quite have the right amount of gold to fill my trailer up. So what does this extreme SG in gold mean in practice? Once gold breaks free from the load, gravity starts to pull it down relentlessly. Gold does not want to move. When it does get moving, it's looking for any excuse to stop. So reading a nugget shape is a good indicator of the distance it has traveled to get there. So if the nugget is round and smooth, it's generally traveled a long way, almost certainly by water. If the nugget is prickly and a spiky bit sticking out of it, then it means that you're very close, possibly very, very close, maybe less than a meter away from the actual source. Gold still attached to quartz and prickly means you must probably even closer. So we've covered reef gold and alluvial gold. But there's a third type that most people almost never talk, and it might explain some of the weirdest nuggets ever found. Secondary or supergene enrichment. This is where gold is transported out of a quartz vein and moved, usually by groundwater, and reprecipitated somewhere else. In WA, the groundwaters are hypersaline, often many, many times saltier than seawater. Over time, these chloride-rich solutions can actually dissolve gold out of the normal lode system. As the groundwater moves through the system, it starts to chemically interact with the gold in the quartz vein, or those pieces that have fallen out already. That's when these solutions hit iron-rich zones, and the gold starts to drop out of solution, sometimes generating very high-grade zones. This process can slowly strip gold from large volumes of low-grade ore and concentrate it in a much smaller area, dramatically upgrading the effective grade of that zone. Personal experience? I've seen saprolite that is thoroughly decomposing bedrock running 10 plus grams per ton beneath a quartz reef that was only doing 1 to 2 grams. That's supergene enrichment at work. Over the years, debate has ranged. Can supergene processes actually grow new gold nuggets? Scientifically, this is a controversial topic. Studies have been done at various agencies on the origins of gold, and so far all have said they are 100% magmatic. In other words, they came up from deep in the earth. But these studies have only been based roughly on about 200 nuggets that have been tested so far. And when you think about it, that's a very small fraction of all the nuggets that have ever been found in Australia in the past 150 years. And I would imagine there must be well over 1 million nuggets found, especially when you consider everything from 1 gram to thousands of ounces in size. If you ever get the chance to chat to any of the old timers, they will tell you about big gold nuggets with tree roots running through the nuggets, or nuggets containing inclusions of decomposed rock. It's hard to explain if all the gold formed billions of years ago. Where was the trees? So when you get out in the field, here's how all this information can help you. Read your nugget. You find your first piece of gold. Pick it up and have a close look at it. Clean it off a bit, have a look. Is it flat, with striations on it? Maybe a little bit rounded in places? It's a good chance it's water-worn. If it is, see if you're standing in an old creek bed. It may not be obvious. You may be standing in an old paleo channel. See if you can find where it's come from. If the gold is prickly, or maybe even crystalline in nature, then you could be right on top of the source. Slow down and start gritting the area. If you find gold in saprolite with no obvious reef, you need to start thinking supergene gold. Small pieces of gold can be moved also by biological processes. By biological processes. That's a difficult one to say. Tree roots can push deeper material up to the surface, and termites are thought to carry fine particles all the way to the surface and deposit them on the mounds on the outside. So don't ignore gold in strange soil contexts. It may have been brought up from an enrichment zone deep below you. So once you find a small piece of gold, stop. Take a good look around and try and figure out how far it's traveled. You may be standing on an amazing spot. If you don't think about it, you could be walking away from a very rich spot. So please, stop walking away from your gold. If you find a piece, the formation science says there's likely more nearby. Grid the area. Go deeper if you can. And think about the processes that put that piece of gold where you found it. Just by understanding this info won't guarantee that you'll find more gold. Nothing does. But it will put you miles ahead of the next guy who just wanders around hoping for the best. I hope this has been of value. If it has, I'd really appreciate a like, leave a comment. I'd love to hear about the types of gold you've been finding and what you reckon the story is. If you haven't subscribed, please think about hitting that button.